Holy cow, that's loud. Hello, everyone. Welcome to South Carolina Linux Users Groups, the Upstate Carolina Linux Users Group here in Greenville. Welcome, everyone here in OpenWorks. And ColaLUG, the Columbia Linux Users Group in Columbia. I don't think anyone from that group is here tonight, but that's okay. They're still here. We're still all part of it. Tonight, we have Linux virtualization. I'm really excited to talk about this, and we've had a request a couple months ago, in fact, about virtualization. So this is great that Bill Jackman has offered to talk about it, and I will let you take it from here, Bill.
Awesome.
Thanks so much.
All right. Hopefully we have a screen share. Going once, going twice.
I can see it.
Fabulous. Perfect.
Olivia, you can see it?
Yes.
Okay, it was because I got kicked out of Jitsi. You'd be reconnected. So
Okay.
All right.
Can you hear now?
Better on sound.
Olivia, Arnold? Yes. Okay.
Perfect. All right. So Genesis was a discussion we had in the mailing list, and then Broadcom's actions to change how VMware is licensed. So that prompted a lot of talk about Proxmox, Kubernetes, Nutanix, Harvesters, all these wonderful virtualization technologies we have. And to start with, we're going to do a virtualization intro, so just level set what virtualization is. The definition that I picked is that it's a technology that is applied for sharing the capabilities of physical computers, splitting those resources among OSs. So it can be as big as a mainframe down to as small as a little Docker container doing something on your laptop. So types, basically two types, virtualization versus containers. And then virtualization can be split further. You can either have the hypervisor sitting on the bare metal or a hypervisor sitting on the host. And then for containers, you're actually having that container runtime split into the hypervisor portion, where that is running on your host operating system. We can get into some Kubernetes running bare metal, but still there's that container runtime sitting somewhere connected to some operating system. So virtualization, or my learning doing this presentation, it also gets acronymed out to V12N, and the 12 is the number of letters between the V and the N, kind of like the internationalization shortening. And Kubernetes, there we go. Didn't know Kubernetes, thank you. Never processed, never processed. So what year do we think Kubernetes started in? Or Kubernetes, I'm sorry. 2008, by the way. What year do we think virtualization started in? And the folks that were here for the preview don't get to answer. So was it the 2000s? Was it the 90s? Was it the 80s?
60s, 90s.
You were here. So one vote for 90s.
70s?
60s.
Okay, closest without going over. 70s is pretty close too. So it actually started with the mainframes. So IBM, when they were developing what would become the 370, so if you've read Fred Brooks's The Mythical Man Month, that was around the same time this was going. But for the 370, the magic for the CMS OS is each user got their own OS on the mainframe. So it looked like I was the only one using that mainframe, even though there could be 10, 20, 30 terminals on it. For me, I was the only one. And that's where we started our virtualization journey. So one of the instructors I had early on in my career, actually, he started all of his presentations with, we already did everything you're working on. And he would call PC people open systems people. We've already done all of this in 67, 68, 69. And he would go off about how much space it took, how much money it took, how much power it took to achieve this, and then go, and it's all sitting right in front of you in a laptop, or if he was still around today, I would expect him to go, and that cell phone, that was 3 floors of a building. And I've spent all this time trying to prove him wrong, and every time I do any type of research, it comes back to, yeah, that was done in IBM in 67, 68, 69. That's where our beginnings happen. And then we had hardware assisted happen in 72 for the person answering in the 70s. So you actually had the hardware helping out that virtualization layer. It wasn't trying to do everything in software. And then the real magic was the SEI instruction that was in the IBM. So that was the next evolution. And we'll get to see the same thing happening for x86 architecture in about 20 years. So our next major era in virtualization is PCs. And for me, the first one I was introduced to was boxes. So being able to do that emulation, boxes is still used today to be able to emulate hardware. If you're developing an open source or a operating system, right? You'll be able to attach boxes to give you a consistent hardware platform to be able to develop your OS. And then 99 for me is where I came into virtualization in my career, where VMware Workstation, where I didn't have to load up physically unique boxes. I could have one test machine that was running multiple images. 99, you also had Xeno servers come out, which is what would become Xen for Citrix years later. 2001, you moved from, hey, it's a test workstation for a technician, to now I'm running server workloads with ESXi and GSX, I think was the first one before they moved to the ESX branding. And then QEMU comes out in 2003, and that starts to be like the next level of boxes. We'll see that pop up again when we get to Proxmox. QEMU is how Proxmox accesses Linux KVM and the kernel virtualization module, and that's how it provides the VM components from Proxmox, is actually using QEMU. So hardware to the rescue. So one of the problems before we saw VTX come out and AMDV, which is the same thing just for the AMD extensions, was that it was slow. So you'll see marketing where virtualization, it's only cost 1%, 2%, 3%. And that's true because of the hardware virtual assist. So the same thing we discovered in the mainframe era is now becoming true for PCs, where we had that huge performance penalty and then we had hardware come in to assist us. And then with that hardware gas, we start seeing containers pop up. So first OpenVZ, which was one of the first container technologies, if not the first container technology. And then we start to see the beginnings of AWS. So S3 and EC2 come out in late 2006, leveraging again this virtualization that's been sped up by hardware. 2007, we have Linux KVM, so the kernel virtualization module, which lets Linux expose that hardware acceleration up to the stack, essentially being leveraged by QEMU at this point. VirtualBox, so we had chatted about VirtualBox, which is one of those type 2 hypervisors, so it sits on an OS and enables it. This is kind of the open sourcing of VMware Workstation. So in 8 years, we go from I'm paying a closed source license for this technology to, hey, it's now available for download and I can start to use it almost immediately. 2008, we have Citrix Zen. So our Zeno servers from 99 moved from being a research project to being a product from a large company. And Hyper-V also gets introduced. So you have that VMware competition start to take place. Proxmox is released in 2008, and its original design is to be a GUI for OpenVZ and a backup solution. So how do I back up these containers? And then LXC, which is the Linux containers, is also formed around this same time. And that will also come more into Proxmox because that is its container technology. They've pretty much swapped out the OpenVZ for the containers. And after we move from that PC virtualization, we're seeing containers pop up. So one of the components we were talking about earlier is that rush to containers for even businesses now. So 2013, we have Docker come up. 2014, we have Kubernetes, and the precursor project inside Google was called Borg, and that actually happened much earlier than Kubernetes being released, but this is Borg for the public, right? Another project that's dear to my heart is KubeVirt, so that lets you run VMware workloads on Kubernetes, so you can treat it almost like an orchestration layer for even VMs without containerizing them. And then 2022, SUSE has a project called Harvester. And that is a hyper-converged architecture. So it will run Kubernetes, so containers on Kubernetes, and it will also run VMs via KubeVirt. And now we're going to switch into deep diving in Proxmox. So originally I had intended this talk to be Proxmox. And then based on mailing list discussions, it was, hey, we need that primer before we jump in, right? And there are a lot of amazing other tools out there, like Harvester, like Kubernetes, that are available. So Proxmox, again, started in 2008 by Dietmar and Martin Maurer. It is based on Debian Linux. So if you open up Proxmox, you'll see a Debian kind of service control interface if you're familiar with VMware. But you'll see a Debian instance underneath, and you can actually install Debian and then load the Proxmox repo and install Proxmox on top of your own Debian instance. Supports KVM and LXC. So again, KVM is the Linux kernel virtualization module accessing that hardware assist that we saw Intel merge in, and it's accessed via the QEMU. LXC replaced the container component, so it replaced OpenVZ, and that's how you do containers. We had a side discussion also on the mailing list for how do I get Docker on there? So a lot of workflows for containers are synonymous with Docker still. So the way you would do that in Proxmox now, if you're not using LXCs and being native at the OS, is you would install Docker either into the Debian instance, which Proxmox generally doesn't recommend, or you install another VM and then run Kubernetes kind of VMized, right? Or Docker VMized. But the issue you run into there is one of resources. So I'm paying the virtualization penalty for the VM, and then I'm running Docker in this VM. I'm now paying that penalty against some kind of virtualizing the virtualization. So I'm nesting. So you start to pay more and more of a penalty as you nest those virtualization instances. And then Proxmox is a wonderful GUI. So you'll be able to create a machine, move a machine without dropping down to the command line and entering the QEMU commands to stand up that virtual machine. So learning about Proxmox. So there's the administrator guide, which currently taps in at 336 pages. That's pretty dense for an admin guide. But that can go, hey, from beginning to end, that can kind of get you all the info you need to stand up Proxmox. I'm a big fan of actions, so being able to actually just load it in your home lab is a great way and how I normally learn. And then there's a couple of YouTube channels that I'll throw in the chat for, hey, here's just a walkthrough of starting from Proxmox, beginning to end, from hey, I'm going to install it, to hey, I'm loading a complete home lab VM setup on it. And then where to ask questions and get an experience for the Proxmox community. So for any open source software, it's really about your community and what support you can get. So there's the Proxmox forums, which are incredibly entertaining. Reddit is another great one. Level 1 Techs will have a forum dedicated to Proxmox. And then there's a helper scripts concept where people will post into a GitHub for all of their scripts that have made Proxmox more useful. So whether it's, hey, here's how I create this container, or here's how I do this other thing, there's probably something in helper scripts that will help you do that. And then how I use it. So Proxmox probably about a decade ago replaced ESXi free in my home lab, mostly because I had to keep on remembering to go in and go, yes, I'm using an unsupported processor. VM will give you that message, and then you have to give it a boot command to go, yep, I know I'm unsupported, load it anyway, you'll work just fine. Proxmox didn't give me that, so eventually at one point in the reload of the home lab, just got frustrated and went, Proxmox doesn't do this, let me load Proxmox. And then for me, the feature for Proxmox that's nearest to my heart is the link clones. So I can spin up multiple test instances from one. And the way the storage works underneath is if you're using LVM or ZFS as your storage solution, you are able to just track changes for each version that you spin up at a storage layer. So if my VM is 100 gig, but I'm only changing 1 gig for each instance, I'm only watching my storage be removed by that 1 gig. And I'm not, hey, I want to spin up 10 of these. I'm not needing a terabyte. I'm needing the base image plus whatever changes I'm making to each one of those instances. And then futures, so Terraform, which is an infrastructure as code language, actually has a Proxmox provider. So you can start to Terraform your Proxmox installations. So basically be able to give it code that will build out a VM or create my link clone from my VM. The other component released with Proxmox 8 is the software-defined networking, so SDN. So you're able to actually, from inside Proxmox, leverage VM or VLAN configurations and drive those out to your network. And then for me personally, since 2013, 2014, I've been avoiding containers studiously and being able to leverage more of the LXC functionality and doing more things in containers. So again, making it go faster, right, at the end of the day, where I'm able to strip out that OS component and just have use the same kernel and just have the application and libraries that I need. And that is pretty much it. See, a minute a slide.
No doubt.
So questions, comments, thoughts, how are you using virtualization? How do you want to be using virtualization?
You just, in your history, you mentioned that when they added hardware support for virtualization, that then they could start advertising 1%, 2%, 3% overhead. Do you have any ballpark on what the overhead was before that?
For me, I could run 2, maybe 3 virtual machines. So it was more like you were having it, right? Like when I was running VMware Workstation in '99, I could do the host OS and 1 more, maybe 2 more. And after that, things started really slowing down for me, right? Like you try to do 4 and it just kind of gets slower. So for me, it's almost like you're having it each time, right? Or, hey, I'm running the base OS and another VM. You're splitting it that way. So 50-50 to each. I had 2 more quarter. So it was more for a 1-for-1. And that's anecdotally my experience, right? I can still see some of that today. So one of the things I do for my Linux laptop is I will leverage KVM via Overt is my manager there. So I'll use that to interact with the QEMU that's interacting with the Linux KVM underneath. And that about the same thing. I normally run out of storage IOPS first. So the storage starts behaving a little weird. But even processor-wise, it's maybe 1/10 for any given, like if I'm pegging the CPU, I'm getting about 0.1% when I look at the OS. So for that, it gets a little better. For me, I'm still, even at home, using the Linux KVM on the laptop. I'm probably 2 or 3 if I'm using it on something beefier like server gear. probably 10 is about where I'd max before it's like, hey, the next one just adds a little bit more.
Is there something like the BuildX system for LXC or something that's...
I don't think I'm familiar with Plex.
Okay, yeah, I mean, it's basically just where you can coordinate different nodes.
Okay.
And virtualization like QEMU for my previous job, I was using it to build images both for x86 and for ARM at the same time.
Oh, that's cool.
Yeah, it was pretty nice.
You should do the next one.
Sorry,
He made me
it's
nice.
it's the management layer, it's the build layer, what is it?
I'm not entirely sure, but it's basically you can use it to manage like multiple nodes on your network, and
you're not referring to BuildX Docker.
yeah, Docker BuildX.
Oh, okay.
Yeah, it's just part of Docker. So I was just curious if there was something like that for LXC, because Docker does seem to be a little bit kind of overkill, or just a little heavy on the resources. So
Well, Docker, right? You can decompose Docker into, hey, I got the build script. So like when you look at Red Hat, they've gone to Builda to do the build, Scopio for the repository, and then Podman for the actual container runtime.
mm-hmm.
So I could see you splitting out Docker that way. So BuildX extends Docker build. I don't know if there's an equivalent for LXC, but I would assume you're going to use like Builda or something like that to build your containers, and it probably would be scriptable, just how your entire build chain can be.
Okay, I'll take a look at it. Thank you.
Yeah. Love to see the presentation on it.
And Podman does have Podman. Probably something in Podman. Maybe inside the container for that though, right? Are you saying you think that Podman can make the container the LXC? I don't know. I'm not sure.
One question is we've got, I feel like we've started to hit the limits of some of our CPUs, and they've started to add in hardware modules for like video acceleration or encryption and things like that. Is Proxmox able to, at least on like the big vendors, utilize those hardware modules that do specific things, not just CPU?
So you can do PCI forwarding. So like if you have don't make them anymore, right? But if you had like a crypto accelerator sitting on your PCI bus, you could take that and forward the entire PCI bus into the host. So you'll see that a lot with video cards. So like if it's not like an NVIDIA grid where I can chunk the video cards separately. So like normally you can split them 2 to 4 ways and then push them into 4 different VMs. You can just pass through the entire PCI device, and that presents to its host as if it's there. So like it's if it's physically plugged into them, you can't move it around, right? Because like if I pass something forward, that card needs to be there if I try and move it to another host.
And similarly, something like the secure enclave isn't, if
Secure enclave, I don't know.
Yeah,
like
but
that.
If the host machine is using it, it probably is not available to the machines and Proxmox.
You can do like a virtual TPM idea. So if you were trying to do that TPM, but again, I have questions, right? Because some of that's supposed to be guarded by the coprocessor on the TPM, and now I'm virtualizing that, right?
Yeah. You should run CUDA's on Docker too.
Just to continue off what you were saying, Andrew, you could also like virtualize a NAS device and pass through the entire HBA card.
Virtual wires and I still struggle with that. So you were saying CUDA's. Continue.
Well, I mean, I
So
think you could
Mike-
run, or you could just run a Linux instance on a virtual machine, and then it'll access down to the hardware.
If you're running old hardware, also watch out. Some of the drivers and some of the older hardware are really finicky about allowing virtualization pass through. NVIDIA, I remember like 5 years ago or so, you had to have a dummy HDMI plugged into the back of the card to pass through a proprietary.
If you're using server grade cards, right?
Yeah, server grades will work.
You don't need that pass through. If you're using consumer grade, I have to have at least one monitor in the consumer grade for the card to light. So if you're not plugging in a monitor, you have to plug in something that pretends to be the monitor,
so you
right?
just get an HDMI with a resistor across the right
Yep.
pins. And that does it.
and pay $16 for it and go, why? So as we were talking about that, one of the other thoughts that popped in as you were saying server grade, right?
By the way, you'll need to share your second screen.
Oh, yeah, hang on.
Before you go any further,
Needed to guarantee compatibility with the TV.
Hey, Bill,
There you go.
there's a comment in the chat here from Thad says, I just started with Proxmox after struggling through building LXC, LXD, and GUI setup on Ubuntu server and looking at multipass and microstack. The machine is underpowered, but I am just learning it to run through a Lean Linux TV tutorial. What hardware do you run? Oh, sorry. What hardware do you run in your home lab? Specs.
So I run everything from an old HP thin client with like 16 gig of RAM, which doesn't do much, right? Like we're back to the same thing with my desktop is I can get 2 or 3 virtual machines. Then if I add more, I start to slow down, all the way up to an old super micro board that I have I think 512 gig of RAM in. And that is dual proct, I think 20 cores. That's kind of my main one that I'm shoving 10, 12 machines on right before that one drops. But really it's whatever you have, you can virtualize off of it. That's kind of the magic. It's just how much can you virtualize off it.
what are you doing with all those machines?
Just goofing around. Like there's a jellyfin instance in there. There's yeah, exactly. You build it up and then you do something silly and you go, there you go. Nuclear power is here for a reason.
What is the oldest operating system you've virtualized? Like DOS 4?
No, I've never gone down that dark path.
You could probably run a lot of those on that 8 gig machine or 16 gig
You
machine.
probably yes. I think the oldest thing I've virtualized is probably like a Windows 95.
So a DOS machine.
Effectively, yeah. There's DOS in there somewhere, right?
I just ran free DOS on a 16 gig thumb drive. It was great.
So while we were talking about all of this discussion, one of the things that I thought of is we talked about the hardware virtualization. When you get into more virtualization, you're seeing more virtualization on NICs. So you'll see smart NICs or DPUs. So we're talking again about the offloads, where now I'm having my NIC be intelligent. So if you dive into if you dive into AWS's architecture, it's also possible in VMware, but AWS actually runs smart NICs or DPUs called Nitro, that they're actually running the virtualization software on the smart NIC inside of AWS to be able to have more of the physical CPU in that server available for customers to buy versus 1 or 2 CPUs driving the virtualization software. So all that's done off your network card, which is just fascinating to me. We'll grab a link for that too.
We have some of those smart NICs for our data center.
They're amazing, right?
I don't think anyone's been brave enough to actually try to program on them directly yet.
So I'll throw that link in the chat for the AWS Nitro. That I haven't seen at the home lab yet, but I am looking forward to when I can pick up a used card, put it in, and that can actually run Proxmox, which would be awesome. That is futures though. So that's one component, is that storage virtualization when I can get over here. You're also seeing it, so we have that comment that I can forward an entire HBA in and virtualize my NAS. So that's another component that's experiencing that virtualization. And then SRV.io is kind of that universal technology around this, and that'll drip into PCI as well. but it's very, very cool. Absolutely very cool. So virtualize all the things would be a good summary.
One question on Proxmox versus other, virtualization platforms. How do they have a domain specific language or just a GUI interface to define like resource limits? Like Kubernetes has YAML to say
yes,
this much.
you can go in and define shares inside the interface. And you can kind of limit, hey, you get 1,000 or 2,000 shares out of whatever the pool size is. So that is there.
Okay. And they have a kind of standard format that if I go from one machine to another, I can copy my configs and all that.
That you'd have to back it up. So that's where I got one of my Proxmox horror stories was I was using ZFS and I caught corruption. And because it's a home lab, we don't back up home labs, right? So I'm sitting there trying to recover the ZFS enough to at least get me my like raw disks, right? That's all I wanted at the end. But that would be saved with a definition file in Proxmox, which is stored inside of that Debian instance. So not wherever you're storing the machines. But if you lose that, you've lost now the definition for, hey, how is your machine configured? So how many CPUs are you getting? How much memory are you doing? Where are the disks? How am I putting those disks in the order and all that? All that goes away.
Okay.
So that is my horror story of have a backup of that info, because rebuilding it by either hand or guessing of going, let me boot this disk. Okay, that's not it. Let me boot that. Oh, that's not the one I'm looking for.
You did say there's Terraform support coming, or
There is a Terraform provider. So Terraform I've only ever used in the context of AWS, Azure, right? But the thought of being able to test that first on my Proxmox instance, and there's also a Terraform provider for VMware, right? But you have to have the template already in VMware, so it's not like your idea of that build script that gets me from, hey, I'm just going to give you some raw OS binaries and you're going to run through the install for me and do my configs. It'd be partners, right? So Terraform is more about defining the infrastructure, and then Ansible would be about defining the config from that OS level out. But there is some bleed over, right, that you could accomplish.
I'm just saying you can get like kind of a system backup if you did it all in Terraform.
Yep.
And so if you lost it all, assuming you got
You're feeling why I'm going Terraform. I kind of like this idea where it's going, I have a text file that tells me which hard disk was which. Yeah, go. Give me that back and I'll just copy things back in, right? So that's actually one I have done before, particularly when I was rebuilding after my disk failure, is there's a lot more flexibility in that than what's exposed in the GUI. But again, kind of like the Proxmox originally starting for OpenBZ.
Question on just the container space of it. You familiar with like systemd containers? And, like, how do they fit into this landscape?
I didn't know systemd had containers, so that's
The question
awesome.
was about systemd containers.
Yeah.
Anybody else a systemd expert?
I don't know if it's like also the same as
Are
LXC.
you talking about
Talking
using
about the
a
same
systemd, making a systemd service that makes a Linux container? Because a systemd doesn't containerize, does it?
You can start containers, so
Yeah, you could use it as a service to start a container.
we can start a container, so systemd unit file. Nspawn, I'm curious.
Just Nspawn,
Nspawn,
yeah.
okay.
Namespace container.
Oh, and it goes back to the Arch Wiki. That's awesome. So per Oh. That may just be me talking. I have awkward pauses.
Well, Andrew's reconnected.
Okay. Oh, we went overtime.
No. He's changing Wi-Fi.
Oh, gotcha.
We're only 35 minutes.
Oh,
So does anyone online have a question?
Next up is a live Proxmox installer.
no, I thought about doing that and it did not work out well. So I'll do my
Oop.
link dump.
Oh, okay. Could you save the links?
I can,
And
yes.
then
I,
send it.
you and for LXC, right? Same way it was originally envisioned by the two folks as OpenVZ is amazing, but the command line is hard. So we created a GUI for that to make OpenVZ more accessible. And how to back it up. Yes, sir. I'm sorry.
All right. So you're saying that it's a wrapper around QMU.
Yep.
See, I guess I assumed it was KVM.
Well,
But-
KVM, so QEMU is between KVM and Proxmox. So Proxmox is driving QEMU, which is how they're accessing KVM.
But since it's a wrap around QMU, it doesn't have to be the same architecture that you're running.
I have never
because
seen
QMU has all architectures.
Yeah, I think you could do the emulation in there. I've never seen a GUI for that emulation.
So I could run ARM on Intel, for example.
Potentially. You'd probably be dropping down to your You'd probably be dropping down to the QEMU level to define that and get it running.
Okay.
The other way, UEMU to do x86
Yeah.
on my Mac.
There you go.
Right.
I've done that, but I guess I never went and looked. I didn't go and look and see if I have done that. I've done my Raspberry Pi emulated on my Proxmox, but I never sat. I never like went and looked to see like what. I did. Proxmox itself. Like I don't want to put anything else on there.
So prior to, I think, Proxmox 7, that was actually the way, right? Where I load Docker into the Debian layer and I run it. And they've since, pretty much when they were still using OpenVZ, that was completely possible. You didn't interact with anything too horribly, right? When they switched to LXC, that was when trying to do the Docker thing became unrecommended, and you got to the point where might have a system, might not have a system. So I think that was the kind of demarc point where they tried to automate more of the container things and kind of block that. I can kind of merge the two technologies together, right? Kind of like mixing a drink. I can put Scotch and gin together.
But should you?
Yeah, exactly. Exactly.
Another one for Proxmox runners is stay on top of the updates. If you get behind by 2 versions, the official path is go F yourself.
Yeah.
In order to do an upgrade at 2 versions old.
Always hit the upgrade. Yes.
Yeah.
Yes.
I'm on Proxmox 6 on one of them, and I'm like, okay, so I have to spend a weekend like redoing this. Yeah, there's not a direct path of 6 to 8. You can do a 6 to 7 to 8, but it is like it's so long.
That was during the time of my ZFS failure, so I ended up just installing 8 to go with.
So I'm curious now if your questions are because you are a NixOS guy and there's a whole different perspective. I mean, it's that I take it you've done some of this sort of stuff with Nix directly.
I mean, that's where I heard about this systemd nspawn thing. I have not used it, but in NixOS you define systemd runs everything. So this is a way you could define whatever you want in a NixOS config and run it as these lightweight pseudo containers. I'm still not entirely sure what the nspawn is. Yeah.
You're expounding, so
Right. Yeah. Sorry about that. All right. So yeah, from what I understand, the all these solutions essentially use the container systems of Linux. I've been doing a little bit of Kubernetes certification training. They go over this where they talk about namespaces in Linux and BSD jails and all that type of stuff. Yeah, it's all just super fancy CH root, but yeah. So I mean, they basically all just kind of use the same technology with their own little things added into it.
It's turtles all the way down.
That's already my experience with virtualization. I mean, I don't know if I need the microphone. I was just going to rant that my experience with all the virtualization stuff is turtles all the way down. Of this, like, let's make an abstraction for our abstraction.
Yes. Well, that's Wheeler's algorithm, right? Like every computer problem is solvable with another layer of abstraction.
I swear, every client engagement every year, there's another thing that sits on top of the thing that was already on top of Kubernetes, that was on top of Docker, that was on top of the hypervisor.
This sounds like how we get VC funding.
Yeah.
All right, so we need nspawn.
What's the purpose of having Docker?
Faster.
Yeah. It's faster?
So
Pre-roll
pretty
too.
much, yeah,
Okay.
containers will basically use your kernel. Yeah. So we're going to stand up. So pretty much your hypervisor layer.
I take, could you use your mouse instead?
Oh, there we go. Maybe. There we go. So pretty much with your hypervisor layer here, that becomes your runtime layer. But what's under here is just the kernel. So I'm not loading up a kernel, loading up another kernel, loading up another kernel, and them all competing for resources. I'm having that one kernel, and then pretty much my application of my library is sitting in my container using that same kernel effectively. And that's where the C groups come in, right? Because that provides your isolation. So instead of a VMware escape from a security perspective where I land in the hypervisor and then I can access all the workloads, if I do a container escape, I end up on the kernel and then have access to that entire system, right? And the C groups theoretically are there to prevent that, prevent me from seeing my workloads to my left or to my right, right? But the speed comes in where I'm not duplicating that kernel over and over and over again. It's I got the one kernel and then its scheduler. I'm not trying to have the hypervisor try to schedule while the kernel is trying to schedule its processes and balance that across hundreds of processes, right? So that's where your performance magic comes in. And then who knows what they decide to virtualize next, right? Probably, like the Meta, if they ever get around to creating the metaverse, right? That'd probably be the next one. The other thing that's loosely tied to it, but it's tied to cloud, is the idea of a digital twin. So being able to take like a manufacturing plant in reality and duplicate that in software. So I can then go and go, hey, I'm going to test this process line change in the digital twin that's replicated from reality. And I can go, hey, if we make this tweak, if we swap in this different mill, right, we'll speed up our production by 15%. And I now have that data from the digital twin generated from the data of the actual manufacturing line to go, yes, that is true. We'll get 15% out of it. Is it worth it to do that swap, right? And you'll actually have hard data around that it already running. You want to test the new recipe on that line. I do it in the digital twin and go, oh, hey, this breaks down. This value goes to infinity. Why? And then you can map that back to your physical world. And that's Siemens actually did a great talk with Amazon on that, where they were taking your Siemens PLCs in the plant and then duplicating them up in Amazon to where your PLC code is actually running in a digital version of that PLC. And it's just like, yes, yeah. Where was this 30 years ago? Where's it going? You broke the pilot line again. It's like, yeah. Well, the goal was to generate more and fascination and interest. And I think I've kept a good running of the links, so I'll also throw all the links into the mailing list too.
Any more questions? Online, any more questions, anyone? Then hearing none. Bill, thank you so much for your
Always welcome. Thank you all for the questions. That was the even better part.
Well, thank you. As always, looking for future presentations. Next month, Jim is going to be talking about automation. Automating. Oh yeah, I need to. Sorry about that. So, I don't know if this needs to be on the stream, but anyway, I'll say it anyway. Yeah, next month, Jim's going to be talking about automation, automating stuff with whatever he was going to give a presentation on. And then after that, we're kind of open. So anyone in Columbia or anyone online, you can give a presentation online from your house if you'd like, or go to your favorite coffee shop and talk to us from there. It'd be great. So I'm looking for presentations for the rest of the year. And otherwise, I think we'll call it a night. Good night, everyone. Good to see you. Thank you so much. And we'll see you. And I'll disconnect this stream somehow.